Welcome to our lecture online. One of the things that resistors do when you send the current through the resistor, and let's indicate that, so the current going through the resistor, there is a resistance here, it dissipates power. Energy is lost by pushing current through a resistor because of its resistivity. And the power dissipated, or the power consumed, is equal to the current squared times the resistance. Now, let's say that the current through the resistor is not a constant current. Let's say that it varies according to the equation C times time squared. And let's say that we allow current to flow through the resistor for 5 seconds from t equals 0 to t equals 5 seconds. What is the total power dissipated through the resistor? Well, we no longer use the steady state equation, power equals I squared R, because I is now a varying quantity. So what we can say is that we can figure out the amount of power produced or power consumed or power dissipated by the resistor for a very small period of time. So what we can say is a very small amount of power consumed per unit time, dp dt, is equal to the current flowing through, which is I squared, and we'll use the varying current from our equation right there, times the resistance. Let's say the resistance of that resistor is equal to R. All right, so a very small amount of power has been dissipated over a very small amount of time according to this equation. At that moment, the current was equal to I, and the resistance, of course, will be constant, equal to R. So we can then write that dP, the amount of power consumed, is equal to the current at that moment times R times a certain amount of time that has elapsed. Okay? So what we can do now is we can say that means the power total is going to be equal to all the summations of all the small little power dissipations over very small periods of time, dP, from time equals 0 to time equals 5 seconds, which is equal to the integral from 0 to 5 of I squared R times dt. Now, of course, we know that I is equal to C times T squared. So what that becomes is this is equal to the integral from 0 to 5, C squared times t to the fourth power, because that would be I squared, times R times dt. All right, now we can pull out the C squared and the R. Those are constants. So these are equal to C squared times R times the integral from 0 to 5 of t to the fourth power dt. And then, of course, we go ahead and we integrate that. This becomes C squared R t to the fifth over 5. Evaluate it from 0 to 5. Plug in the lower limit, we get 0. When we plug in the upper limit, we get t to the fifth divided by 5, which is t to the fourth. And t to the fourth is 625. So therefore, this can be written as 625 C squared times R. And that would be the total power dissipated over the first 5 seconds after we turn on the current. And that's how we find the power dissipated with a varying current through a resistor.